Okay, Houston, we've had a problem here.
This is Houston. Say again, please.
Houston, we've had a problem.
Acceleration problems. The heart and soul of a lot of physics stuff is working with the 5 master equations we learned in our last video, and we're going to continue that process right now. So hey, acceleration. Let's do our first problem. Remember, the process is I want to identify, what do I know? What do I know? What do I know? What I know? A truck is pulling a caravan. That's a trailer, camper trailer, at 85 kilometers per second south. So we're going to say V1 equals, actually let's do it over here. V1 equals 85 kilometers per hour south. Got it? When they hit a bump in the road, the caravan detaches. Oh, that's bad. If the caravan decelerates at 1.3 meter per second squared, decelerate, so that's going to be A is equal to, now watch this, negative 1.3 meter per second squared. Now we've got an issue. This is kilometers per hour and this is meters per second squared. So we're going to deal with that. And he's going to come to rest, so V2 is going to be 0 meters per second, right? And we're trying to find the distance it's going to take before it stops. Now notice something that's missing in this. I noticed that there's no time in this particular, I haven't given time at all. So I'm going to look here for the equation that has to do with no time. So which one has no time component in it? Let's look. Ah, it's this equation down here. So let's use that equation. So we're going to say the equation that we're going to use, that this is the, if you will, the unknown page. And the equation I'm going to use is V2 squared is equal to V1 squared plus 2a delta d. And I'm trying to solve for delta d. Now simply, folks, we're going to plug this in. What's the final velocity? So that's 0. So 0 squared, of course, just 0, is equal to V1 squared. Actually, before we do all this, we probably need to get them in like units. Right, we've got this in kilometers per hour, and this is in meters per second. So let's jot that over here. 85 kilometers in 1 hour, and I need to get the meters per second. 1 hour is 3,600 seconds, right? And there's 1,000 meters in 1 kilometer. So I get my calculator out, and I do this conversion. So that's going to be 85 divided by 3,600. That comes out to 23.6 meters per second. So that's going to be the number I'm going to use in here. So this is V2 right here, right? Boom. V1 is 23.6. And I got to square it. Again, it might be a little curious, like where do these numbers come from, or these equations? That's coming later. 2 times, he's accelerating at negative 1.3 and delta d. All right, so let's get the calculator out. 23.6 squared. So my calculator says 23.6 squared is 556. So this is equal to 0. Plus 2 times negative 1.3 is negative 2.6 delta d. Now I'm going to subtract 2.6, pardon me, add 2.6 delta d to both sides. That'll also go over to this side. So I can say 2.6 delta d is equal to 556. I did that so I could have all positive numbers. Divide both sides by 2.6. And 556 divided by 2.6 gives me 214. Now what is that? That's delta D, and since we worked in meters, right, that'll be meters. So that means the trailer is going to take 214 meters to stop after it hits the bump and gets detached. Make sense? So this is the process. Identify your unknowns, determine the equation, right? This is to determine the equation, plug them in, do algebra. Does this number seem reasonable? Does it also have the correct number of significant digits? probably I might round it to 210. That's close enough. All right. Let's now look at this next question. A car accelerates through a 85 millimeter stretch. So what do I know? All right, I know D, or delta D, is 85 meters. Got that. What else do I know? I know that reaching a velocity of, so that's V2, so V2 is equal to 27 meters per second. I'm just jotting them down, right? It took 6.3 seconds. 6.3 seconds. What was the car's acceleration? So A equals question mark. Now, by the way, we should not assume that this car started at rest. It's just accelerating through this particular stretch. So let's, which equation? So let's flick back to the equations. Which equation should we use? It's going to be the one that doesn't have a V1, right? Because we do not know, right? If you look back here, we do not know V1. So V1 is not known. And it's not asking us to solve for V1. So what we need to do is use the equation that doesn't have a V1. And that's going to be number 4 here, right? So we're going to use that equation. And that's going to be, we'll write the equation up here. The equation we're going to use is delta D. Folks, you're going to want to have those equations handy dandy, right? Equals V2, I'm not going to put all the arrows in here, delta T minus 1/2 AT squared. All right, now, do we have any unit issues? Meters, meters per second, seconds. No, so I'm a happy camper here. So I'm going to just plug this in. I'm going to say 85, right, is equal to V2, right, is equal to 27 times the time, 6.3, minus 1/2 times A times 6.3 squared. So let's kind of get some terms. So just get the calculator out, right? This is a calculator moment. Oh, that's my cell phone. I guess I could use it as a calculator. So I'll say this is 85 is equal to, I'm going to take 27 times 6.3, get 170, plus, and I'm just going to divide these two, or actually plus, I'll just say plus negative. So 6.3 squared divided by 2. See how I did that? 6.3. So that's going to be negative, I get 19.8 A. All right. Now I need to get all the letters on one side and all the numbers on the other. So I'm going to, now this is going to be weird. I'm going to subtract 85 from both sides, right, algebra, so that this becomes 0. All right, and then I'm going to add 19.8a to both sides, right? And this cancels, and this cancels, and I can say 19.8a is equal to 170 minus 85. Doing this on my calculator, and I get 85. Divide both sides by 19.8. So I take 85 divided by 19.8, and I end up with 4.29 meters per second squared. All right, so notice it's a pretty simple process. You identify your unknowns, you determine what equation, you plug and chug. Ask yourself, do I have the right number of significant digits? I should just round that to 4.3 meters per second squared because there's only 2. Really, just 2 to 3 significant digits is probably enough. So those are some acceleration problems, right? Well, let's do another problem. So here we have some other questions. Let's just jump to the police cruiser problem. He's on patrol moving at 53 kilometers per hour west. So he's got a V1, right, of 53 kilometers per hour. That might be an issue, kilometers per hour. When it receives a notice of an emergency, it quickly accelerates to 94 kilometers per hour. So V2 is, that's the speed, right? So 4 kilometers per per hour. Note they're both to the west. All right, that's the positive direction. Over 73 meters. So delta D equals 73 meters. Determine the acceleration of the police car in meters per second squared. So in this problem, I need to go back to my equation. Boom, where's the equation list? And I need to decide which one of those is going to be the best equation. So think about it a minute. Which one should I use? Right? I'm going to rearrange. I'm going to use the V2 minus V1, or is this one? It's going to be equation number 2. All right? So we're going to use equation number 2. So let's jot down that equation. We're going to say right here, we're going to do V2, squared, is equal to V1 squared plus 2A delta D. Now, we do have an issue. We've got meters, kilometers per hour, and they want this in meters per second squared. So I'm going to have to convert these to meters per second, and then I'll be a happy camper. Now, if you recall, we take the 53 kilometers, remember no slashies over 1 hour, and then we're going to say there's 1,000 meters in 1 kilometer. That will cancel off my kilometers. And then we'll do that fancy 3,600, 1 hour is 3,600 seconds. So get that on the calculator. When you multiply that whole thing out, you get 14. So this is equal to 14.7 meters per second. And you do the same process for this one. I won't belabor that. If you're going now 94 kilometers per hour, that turns out that that's 26.1 meters per second. So those are the numbers we're going to plug into our equation. So V2 is 27, plug this in right here, right? This is 26.1 is equal to squared, is equal to V2, or V1, pardon me, which is 14.7 squared plus 2 times A, and the change in the distance was 73 meters. That's a 3. All right, so get the calculator out. Boom. 26.1 squared is 681, so I'll say 681 is equal to 14.7 squared, 216, plus, now 2 times 73 is 146, right? I can do that in my head. 146 times A. Subtract 216 from both sides. This becomes 0, so 681 minus 216 gives me 1146. That's not right. Do it again. 681 minus 216. Notice I made a mistake on my calculator. I said there's no way that could be that. So that's 465 is equal to 146A. Divide both sides by 146. And we get 465 divided by 146, like 3 or something, yeah. That's going to be 3.18 meters per second squared. Got a little tricky thing by converting from meters and all that business, but that's, yeah. And as a side note, I'm probably going to round that to 3.2 meters per second squared to deal with the significant figures. All right. I think you're getting the idea. Let's do just this last problem. The fire truck is also on his way to the same emergency. It accelerates at, accelerates, A equals 0.75 meters per second squared. For 37 seconds, T equals 37 seconds. How far did it travel in that time? So they're signing for delta D. So now we're going to go back and find what equation we are going to use. So let's go back to our equation list. Here it is. So which equation? I want to choose an equation that has A delta T. Now, we should make a note. We need another variable, don't we? Hold on. Oh, he's from rest. Ooh, I missed that. So what does that tell us? V1 is equal to 0. So I thought, man, I'm not going to find this equation. All right, I figured it out. So now we want to find the one that has V, delta T, and D, and of course, that's going to be this one right here, which is equation number 3, right? So we're going to use equation number 3. Let's type her up here. So it's delta D equals V1 delta T plus 1/2 AT squared. All right, any issues? Meters per second, seconds. All right, so we don't have to play games with all that stuff. And delta D is what we're trying to find. So this is actually going to be easy. We don't have to like rearrange. We just plug in the numbers. So delta D is equal to V1, and V1 is 0. That's pretty easy. Times the time, which is 37 seconds, but it's 0 times 37, plus 1/2 times A is 0.75, times T squared. T is 37 squared. Super easy on your calculator. I'm going to do the 37 squared first. So it's 37 squared times 0.75 divided by 2. And I get 513 meters. Probably with significant figures, I'm going to round that down to 510 meters because I can only keep 2 significant digits. All right, you might want to just say 510 and make as a note. I haven't really been specific. That's going to be to the east, right? Okay. So, folks, again, a relatively simple process. You know your equations. You figure out what you know, don't know, figure out which equation to use, solve the problem. You guys are awesome. See you in class. Awesome. Bye. I know, weird.
Okay, Houston, we've had a problem here.
This is Houston. Say again, please.